maybe get lucky and it worked.
Okay. Okay, 3 to the first power is 3, right? Yeah, 3.
Yep.
No?
So we want to get 27 from 3. Like 3 to the 1 is 3. That's not 27. We're looking for 27 as 3 to some power.
That would be 3 to the third.
3 to the third. Good. Okay. So now we can rewrite this up here above as 3 to the 2x minus 1 equals 3 to the third.
Okay.
Okay, so we just rewrote 27. All right, now I'm looking at your examples just to see if we can like do there's a little shortcut here. It looks like we can. So I'll say this verbally. Since the bases are the same, you can set the exponents equal. You can set
Mhm.
2x minus 1 equal to 3. And again, just to be clear, we're setting the exponents equal there for that purpose. So right there, boom, we got it. And we have to now solve this equation. Could you solve this equation for us, please?
Yes. I'm doing it right now before I give you my answer, so that's why I'm not saying.
Sounds good.
So what I did was first add the 1
Good.
to
Yep.
3, which would be
Yep.
2x equals 4. Then
Good.
I divided by 2, so x equals 2.
X equals 2. There's your answer. And that is everything for number 1. Stop and think.
Mhm. That was quite easy.
Yeah, not too difficult. So let's look at number 2. It's similar, not the same, but it's similar. We have the same two here. We have base of 3, base of 81, and we'd really like to turn that 81 into a 3. Okay, so we want to write 81 as 3 to some power. Okay, and we really hope that it's a nice number. We hope that it's a 1, a 2, a 3, so on to do that.
Mhm.
Could you find that number for us, please?
Sure. 81, okay. Um, okay, so x squared is just x. I'm just trying to figure out. Okay.
Sounds like you might be solving it from after you figured it out. Did you get this exponent here?
No.
Okay, that's the first thing to do. You can't proceed until the bases are the same. That's why I was asking you what 3 to what power is 81.
Okay, give me like 1 second. I'm going to
Sure.
scientific for this.
Okay.
'Cause I don't know from the top of my head. Oh, 3 to the fourth.
3 to the fourth. Fantastic. All right, so that answers that. So you have 3 to the x squared minus 3x equals 3 to the fourth. Because the bases are the same, bases have to be exactly the same, you can then set the exponents equal.
Mhm.
So you write x squared minus 3x equals 4, and then you have to solve this equation. Okay. Could you tell me the name of this equation?
Um, I don't remember it from the at the
So
top.
power of 2, does that remember? Does that help? Power of 2?
No.
All right, so this is a quadratic.
Oh, a
Okay,
quadrillion.
and there's a number of ways to solve quadratics. Do you remember any of them?
Well, we could square root.
Okay, some of them can be square rooted. This one would not be possible because there's 2 x's. You'd have to complete the square first. Do you remember anything else though besides the square root property?
Um, No, not really. I'm sorry.
All right, so let's subtract 4 from both sides. Start with
Okay.
that. So typically you get everything on one side of the equation. That's kind of a good starting point here.
Okay.
Do you remember factoring?
Yeah, a little bit.
Okay, so factoring is probably our best approach here. We're looking for two numbers that multiply to -4, but then add to -3. Okay, so could you tell me some numbers that multiply to -4?
-4 and 1.
-4 and 1. Does that add to -3?
Yeah.
It does. So we can factor by writing x minus 4, x plus 1 equals 0.
Okay.
And we can set each of those equal to 0. X minus 4 equal to 0, x plus 1 equal to 0. What does that become? How do you, what are the x values when you solve for x?
X equals 4 and -1.
Very good. All right, so there's actually two answers in this problem. That's totally okay.
Yep, I would say that's fine.
All right. Any questions on that before we move to number 3?
Nope. I'm
All right,
good.
so just to review here, because the next problem is really, really similar to the first two. In both the first two problems, we take the larger number and rewrite it as base 3. Like in this case, we wrote 27 as 3 to the power of 3. In problem 2, we set 81 as 3 to the power of 4. Okay,
Right.
so this is one of the few times where I can actually give you a problem and say, hey, we have done now 2 examples. It's different numbers, but I'd like you to try solving this. And the hint here is that you're going to make 64 into 4 to some power.
Got it. I got X equals 2.
Okay, that is correct. Good.
Yay.
All right, so the next one's actually pretty tough, but they give you a hint that really makes it super doable. Let me go ahead and snip that one in. Uh, so number 4 here, it says it says to solve 4 to the x plus 1 equals 1 over 64, but they give you a hint over here on the right. That should be enough for you to be able to solve this because the bases are then the same. Um, so let me go ahead and work through that. Let me know if you have any questions.
Okay. This time it's like a fraction. Oh my God.
That's okay.
Yeah. It doesn't matter if it's a fraction. They're giving us already a major hint. I got X equals -4.
It is x equals -4. Good. All right. So interestingly enough, 5, 6, and 7 are very similar, but we'll work through them here. It's really at 8 where there is a bit more work to do, but we'll get through these relatively quickly here. So here's number 5. So notice the bases are already the same. Okay, so you can just set x plus 11 equal to 8, subtract 11 from both sides. So x equals -3. Really not too bad. Yeah, I'm surprised this isn't the stop and think problem because it's much easier than any of the ones we had been doing.
Yeah, I would say this is like the most simplest.
All right. So I'd like you to try number 6 though on your own. Let me know if you have any questions.
Okay. So I have a question. For 8 doesn't have a exponent, so would I just use 1?
Nope. This problem is a lot like the 4 that we did up here. See how these didn't have the same base
Yes.
and neither did these didn't have the same base. What did we do in both of these problems?
Oh, we found a base that worked. Okay.
Yes, it's the same thing
Okay,
applies here.
okay, got it. Thanks. I got x equals 4.
What did you use over here on the right? What was 8? What did 8 become? 2 to what power?
Oh, I did 4 and a power.
So 2 to the power 4 is 2 times 2 times 2 times
Oh, no,
2.
no, no. I meant like I did 4 squared.
It's got to be the same base.
Oh, okay, that's my mistake. Never mind.
Yes.
Let me refix it real quick. Got x equals 9/2.
Okay.
Is that
That
right?
is correct. Yep.
Oh,
Yes.
yay.
All right. So let me have you try. We'll look at 7 here somewhat together here. You're doing great. Yeah, it's good to see you kind of working some problems out on your own. Um, so the hint here is that 1 over 25 is really 5 to the minus 2 power. 5 to the minus 2 power. So that's your hint. Take that and see what you come up with. It is not, the answer is a fraction, if that helps, maybe thinking about it.
So it'd be 2 over -3.
That is not correct. It's 5 to the negative 2 power on the right here. Then you set the
Oh.
exponents equal.
Mm.
So 5 to the minus 3x equals 5 to the minus 2. You set the exponents equal. So what did you write next after this? What's your next line look
Um,
like?
-3x equals -2.
Okay, that's correct.
So then I decide to divide by -3.
Okay, that is also correct. Okay, so I guess it's just a sign issue. These two negatives make positive.
Right, so
They're both positive.
would be 2/3.
Yes, yes. Good.
All right.
All right, so the first 7 problems here are really they're pretty trivial. I mean, they're not like as complicated as the next ones are. The next ones aren't as complicated, but they the things that we just did won't work. So when you look at this problem here, you first would start out and say, like, is there a way to make 29 as 3 to some power? And the answer is no. It is not possible. Okay. So
Yeah.
then you might think, well, what do we do? What can we do to solve this? Well, unfortunately, you have to use a different approach altogether. So your book does this. They show it like this. They show writing the log 3 to the x log of 29. They show taking the logarithm of both sides of the equation, close parenthesis, like that. So remember yesterday we did a bunch of logarithm property problems,
Yes.
maybe? Okay. They're going to come back today a little bit. So if you recall, there's law 3. If you remember, law 3 yesterday allows you to bring the exponent out in front. X log 3 equals log 29. All I did there was bring the exponent out in front. And
Uh-huh.
then this log 3 is really multiplying log 29. I'm sorry, this log 3 is really multiplying x,
Hmm.
which means that you undo the multiplication with division. You divide both sides by log 3. So on the left, it's just x. On the right, it's log 29 over log 3. And now we go to the calculator, okay? I'm going to snip something in though, because it's very important that we get this down. The instructor is very clear about how they want the answer. They want 3 significant digits. That's not decimal places. That's like the first 3 numbers you see, maybe rounded, depending on the problem. Okay. So I want you to give me the first 4 digits that you see when you go to the calculator. And let me know if you need help finding that log button again. You
Okay.
can also just type log as well.
The answer would be 4.85.
Got something different than you. So log, you typed in log 29 over log 3. Should look exactly the way it's written here.
Yeah, hold on one second. Okay, there. It would be 3.065.
Okay, so that's 4 digits. Now 3 significant digits. First digit's significant, the second, and then the third. So we need to decide whether we're going to round that 6 up or down.
We're gonna round it up.
Yes, there's your answer. Any questions on that?
Nope.
Okay, so the next one's somewhat similar. It's a little more complicated, um, but it's the same sort of flow steps here. So we're going to start by dividing both sides by 8. Can you tell me what 876 divided by 8 is, please?
Sure. Just give me 1 second. That'd be 109.5.
There. All right, very good. Now, the next step here is to take the log of both sides using the logarithm of both sides. And you'll notice I like to put the thing that we're taking the logarithm of in parentheses, just to kind of keep it nice and tidy so we know what we're taking the logarithm of.
Okay.
All right. Next thing here is to bring the exponent down. Now the exponent I've also written in parentheses. I've done that in both steps here. Different than these parentheses. They're parentheses around the exponent. So the whole thing comes out in front. X minus 6 log of 3 equals log of 109.5. Next step here is to divide both sides by log of 3. A lot of writing here. So we're almost there. Our goal is to get X completely by itself, eliminating any anything besides besides a 1 in front of it. We almost have it here. Um, how do we undo the subtraction by 6?
We divide.
It's subtracting.
So you add.
Yes, you add 6. And you might be wondering, well, where do you add 6? You just do it off to the side. You just put it off to the side and combine it at the end. It's not in the numerator. It's you divide, you're going, when you put this in the calculator, write this first and then plus 6 to the right. And again, 3 significant figures. So give me the 4 digits you see. First 4 digits you see. Whenever you get to that, take your time though. Make sure you enter it correctly. All that stuff.
Okay. Okay. Um, I got 10.27, but
Good.
if I round it up, it's gonna be 10.3.
I agree. Yeah. Very good.
Yay.
Okay. So number 10 here, the apply your knowledge. This is always something a little wonky compared to what we've been doing. It's usually like a big step up depending on the types of problems we've been doing. So, all right. It does say to see exercises 9 through 11. So that means there's some sort of problem that is related to this. There is. So your class is using this formula. A equals PE to the KT. Okay, and I'll define some of these variables. So A is like the future amount of something. P is the initial amount. You might think that E is a variable. E is actually a function. It's the E function exponential. So we don't need that. K is a constant. And T is the time, typically in years. All right, so let's take a look at this. It says at time T equals 0, there are 500 bacteria and favorable growth medium. So that 500 represents the value of P. It's the starting amount. 5 hours later, that's T, there are 2,000 bacteria. That's A, that's the future amount. Assuming exponential growth, what is the growth constant K for the bacteria? They're giving you all the numbers. They're saying, okay, A is 2,000, P is 500, E is a function. We don't know K, but P is given as 5. So we're just substituting those numbers into the equation. Let me know when you get caught up here.
Yeah, I'm caught up.
All right, so our goal is to solve for K, and in principle, we can do that. There's only one variable, E is not a variable, K is the only letter here. To do that, we're going to first divide by 500. So on the left, it's 4 equals E to the 5K. Now, in previous problems, we were using log to solve. In this problem, we're using ln. ln is really log base e, which I don't know if it was covered in there. It doesn't really matter. Um, there is this distinguishment though between log and ln. Typically use ln most of the time. We could have used it in the previous problems, but it said to use log, so we use log. I would have clarified this in a classroom, but we don't have that option here. So having said all that, we're going to use ln, which I think could be confusing. Like, why aren't we using log? It's because it's e this time. E is special.
Yeah, he's always special.
It's very special. So on the right here, bring the 5k down. 5k natural log of e equals natural log of 4. And then we talked about this, I think, the other day. Natural log of e is really 1. So this part on the right here is really equal to 1. So right now, and I'm just going to rewrite this a little bit. So it's 5k equals natural log of 4. And then we can divide both sides by 5. Now, when you do this, make sure that you close parentheses on ln and then divide by 5. It's not inside the parentheses.
Okay.
It doesn't say what to round to, at least as far as I can tell. So we're going to round like 4 decimal places. It's kind of the standard, and that's part of the course. So
So,
grab your calculator.
so it would be 0.277, but if I round it up, that's going to be 0.28.
Okay, so 4 decimal places is different than 4 significant figures. You got to go out to 5 decimal places, 27725,
Okay.
because you only care about the ones to the right.
Okay.
So what do you round this to? What does that 5 cause the 2 to round to?
It tells us to round up, so it would be 3.
Yes. 0.2773. And there you have it.
Okay, great.
Right. So we're done with that. That's all done. 10 questions. All right. All right. Let's look at number 1 on the next lesson to stop and think. All right. So this problem has some similarities to what we were doing to start this lesson. I'm going to just rewrite it without all the words to kind of clean this up a little bit. When the logs are the same, you can set the part inside the logs equal. So there's not much to do here. You actually just write x is equal to 18. If the log base are the same, you can set the insides equal. It's just a property of logarithms. Now I'm looking here just to see if they do anything special here. They do not. Okay. Well, that's it for number 1. Number 2 has more work. They're not all this straightforward.
Hmm.
All right, so here's number 2. All right. But again, kind of like number 1, it is the same in terms of like they both have the same log base. Log base b, they're the same. Because those are the same, you can set the part inside x squared equals to 4x minus 4. So we set the inside part equal to the inside part if the logs are the same. Looks like that's actually the case in 3 as well. So that's good. All right, what kind of what would you call this down here? What's a good name to give to something like this?
I was quadratic.
Quadratic, good. All right. So we can solve quadratics a number of ways. The most common way is to bring everything to one side of the equation.
All right.
So to factor this, we're looking for two numbers that multiply to 4, but then add to -4.
Um. Hmm. hmm. -2 and -2 and -2.
Yes, very good. This becomes x minus 2. X minus 2 equals 0.
Do we do like the two separate ones where it's like
Yes,
x minus 2 equals 0? Okay. X equals 2.
equals 2. Good. Now we're supposed to actually check the answers at some point. Does not look like the instructor does that in any of these problems, although you are supposed to do that. Um, although it really it happens more often when you have two solutions. This one has one that's repeated. Yeah, we'll get to that when it's applicable. So not too bad here. Number 3 is really similar. All right, so notice that the so they're going to set the x squared minus 56 equal to x. And there's a bit more that goes into this, but according to your notes, you don't have to do any more than that.
Okay.
Subtract x from both sides. X squared minus x minus 56 equals 0. And now you're looking for two numbers that multiply to minus 56, but then add to -1.
-8 times 7.
Yeah. So we got x minus 8, x plus 7, set them equal to 0. Give me those two solutions.
X equals 8 and -7.
Yes. And normally you'd just be happy. You'd say, all right, I'm done moving along. But you really are supposed to check. You're really supposed to check your problem. So let me grab the original problem here. And you may be thinking, well, what do you mean by check? Well, there's a couple of ways to think about checking. One is to actually put the numbers in and see if it's the same. Okay. The other is to look at the domain. Right. So most students want to just put the numbers in. So we're going to do that. 8 squared minus 56. Does that equal 8? Could you check that for us, please?
Sure. I just need you to repeat it one more time because I spaced
Yeah,
out.
just asking you to calculate 8 squared minus 56 and decide if that's 8.
Yeah, that equals 8.
Okay. Now, is the log base b of 8 okay? That's the next part. Can you take the logarithm of is 8 in the domain? And to answer that, if you recall, the domain of log was 0 to infinity. We did that a bunch yesterday. So is 8 in the domain?
Is 8 in the domain?
Yeah, is 8 Does 8 fit between 0 and infinity?
Yeah.
It does. So we're good on 8. 8 is good. Now let's do the same thing for -7. -7 squared minus 56. Does that equal -7?
Yes.
It does. But now, same question. Can you take the log base b of any base, really, of -7? Is that okay? Is -7 in the domain?
Yeah, I would think so.
So when you think of all the numbers from 0 to
Oh, no.
infinity,
No, it won't be. It would be negative infinity.
that's right. So they call this other answer extraneous, and that means that it is excluded. So even though it was an answer to the problem that we were solving, even though when you factored this, you got 8 as an answer, it's not actually an answer.
Uh-huh.
And the reason is it has to do with the domain, has to do with composition of functions. Uh, basically, you want to think of it in short that when you get multiple answers, you should check them, and it's likely that one may or may not work.
Mm-hmm. Got it.
All right. So we're going to move on here to number 4, stop and think. We're having to stop and think a bit more on these today. Here it is. Get that snipped in. Oh, we got it. All right. So this is the first problem we've seen where there's more than one thing going on one side of the equation. Like on the left, there's a 2 in front of the log. Here, there's 2 logs. So this is where you got to use your properties of logarithms, or those laws of logarithms. Do you remember what we can do with this 2 right here? Where can it go?
Let me see.
It was law 3 from yesterday. Do you have any of those laws written down from yesterday?
Yeah, I think so. I'm just checking to see if I have them written down. 1 second. Yeah, I do. I kind of remember the law stuff is annoying because there's so many. Okay, 3. Okay,
What am I showing in red here? What am I
the how
trying
the
to show
2
you?
goes into the x.
Yeah, it becomes an exponent.
Yeah.
The exponents come out in front, or you can bring them right. Now on the right here, on the right, you have a sum here in the middle. Do you remember what law 2 says? I'm sorry, law 1, actually. What does law 1 show you about a sum? What does the sum become?
Hmm, it would so for log 1 it would be, oh my god, this is, so it would be log x base x squared plus 2x minus 2 plus the log base of 2.
We're just looking at the ones on the right here. Just what's going on the right. Do you see that it is a sum there in the middle?
Yeah.
What does law 1 say about a sum? What does a sum become?
um the sum becomes, um
It was in your notes from yesterday. It's a sum to product.
oh yeah.
Sum becomes a product. Right. So uh, that means you multiply the two things and only write one logarithm. Single log, but the product of these two things. So notice now that you have log base b of x squared equals log base b of 2x minus 2 times 2. From the previous problems we've been doing, it's no different here. What can you do now that the base is log base b is the same in both?
It would be. Ugh, why is it so confusing for me? I don't understand.
Well, let's go back and look at a previous problem.
Okay, good idea.
You see that the log base b is the same, log base b is the same.
Yes.
And what did we do next? What did we write this next line?
X squared minus 56 equals x.
Okay. And let's go back and look at the problem here. Log bases are the same.
Mm-hmm.
So when they're the same, you can set the inside parts equal.
Okay.
Do you have the same scenario here?
Yes.
Okay, so what can you write next?
We can write x squared equals 2x minus 2 in parentheses times 2.
So there's no logarithms.
Yeah.
It's all gone. Good. Okay. On the right, I want you to distribute the 2 into the equation. So you have 4x minus 4.
Okay.
Okay, and we've solved a number of problems like this today. So I'd like you to solve this quadratic.
Okay. That would be.
And you'll probably want to factor. That's the most. It's the most common method, and it seems to work a lot.
Okay. So it would be x plus 4. No, wait. There's a -4, so it'd be -4. And then x minus 4 in both parentheses. So
Okay,
x is
we
4.
solved one. We solved a couple like this already, and there's you have to move everything to one side of the equation.
Oh, yeah. So for it would equal x minus 4x plus 4. Sorry, x squared minus 4x plus 4.
Okay, x squared minus 4x plus 4 equals 0. That's good. And from here, you should be able to factor the way we've been doing. Been doing a number of these today like this.
Okay, now in parentheses, it's going to be -4 x minus 4 is in one parentheses, and I guess x plus 1's in the other.
Okay, let's write that out here. X minus 4, x plus 1 like that.
Okay.
Okay, so if you foil this, you should get back to the previous line. Let's take a look. X times x is x squared. That's a good start. X times 1 is 1x. Minus 4 times x is minus 4x. Minus 4 times positive 1 is minus 4. This becomes x squared minus 3x minus 4. Is this the same as what you have written up above?
Yes.
The same as this?
Yeah, I just changed it. Yeah.
They're not the same. No, this is x squared minus 4x plus 4, x squared minus 3x minus 4. What I'm trying to show you is this is a check. This is how you know that it is or is not correct. Okay, so
Mm,
um, you're
so I have
looking
to
for
fix it.
you're looking for two numbers that multiply to 4 multiply to 4, but then add to -4.
Okay.
And we actually did this earlier. This is actually the same factoring that you did earlier.
Hmm. So it would be -2.
Yes. And what's the other one?
Again, -2.
Yes, x minus 2. X minus 2 equals 0. What does x become?
It becomes it becomes like x equals 2, so it becomes 2.
Good. Excellent. All right.
Logs get me so confused.
Yeah, you did real well. I mean, it's tough when we cover multiple sections in a single lesson because there's definitely not time for you to kind of look through it and see if
Yeah.
it's at all familiar, but you did a great job. We'll definitely finish the rest of this on Friday. And if that review is not open, we can just work on some other stuff until then. But that's going to do it for